Hello everyone, we are from RMD Engineering College and greetings to everybody who are watching this video. Here we are about to present our project called IoT based weather reporting system and our mentor for this project is Dr. Shakunthala ma'am. Our team members are Pavitra, Dashita and Monisha. The IoT-based weather reporting system uses a network of interconnected sensors and devices to provide real-time and accurate weather data on a much larger scale. The core component of this IoT-based weather reporting system typically include an array of sensors which helps to determine the meteorological parameters like temperature, humidity, pressure, and wind speed and precipitation. The platform processes the data, applies algorithm for analysis, and it generates the actionable insights that are made available for the users in real time. And now let us see the components which are required for this project. The hardware requirements are Arduino Uno, BMP180 barometric sensor, MQ135 gas sensor, DHT11 sensor, 10K resistor, light dependent resistor, 16 cross 2 LCD display, connecting wires, generic ESP8266, 3.3 to 5 volt regulated power supply. And the software requirement are Arduino IDE and ThinkSpeak website. Component overview. Arduino board. The Arduino Uno which we are using for this weather reporting system acts as a central processing unit which helps in data collection, analysis and display. Light dependent resistor. The LDR detects the change in the light intensity allowing them to access the weather condition like brightness and darkness. MQ135 sensor. This sensor specializes in measuring the air quality, providing the valuable insight for the pressure of the pollutant and the overall health of the environment. BMP 180 sensor. The BMP 180 sensor excels in monitoring the temperature and atmospheric pressure, helps to essentially metrics the understanding the weather pattern and trends. LCD display. Our system utilizes a LCD display to present the real-time data in a clear and user-friendly manner, ensuring ease for interpretation and accessibility for user. And also we are using DHT11 sensor which is used to determine the temperature and humidity. Here is the flowchart for our project. As we already mentioned, Arduino Uno act as a CPU for this project. We have several sensors like MQ135 sensor, BMP180 sensor and DHT11 sensor. MQ135 sensor is an air quality sensor which is helps to measure the air quality around the city. And BMP180 sensor is used to measure the temperature and pressure, and a DHT11 sensor is used for measuring the temperature and humidity. And also we have LDR which is used to measure the light intensity. With the help of the light intensity, we would measure the weather as dark, cloudy or sunny. This data which is provided from the sensor is processed through Arduino, and the output of the Arduino is coded such that the output is displayed in the LCD display. And now let us see the working of our IoT based weather reporting system. At first we have a Arduino board and we are having our BMP 180 sensor. Here is the sensor, and we are having MQ135 gas sensor, and also we having a DHT11 sensor, and we are connected it with the LCD board. And now let us see how it is working. And also we have a LDR and a 10K resistor as we already mentioned. And now let us see our working. And now I am going to connect my Arduino board with my computer using Arduino cable. Now I already connected so that we can see the output. So we can see that the weather now, the weather is dark night, and also we can see the several other parameters such as air quality and temperature, humidity and pressure. Let us now see the output. We have to code our Arduino in such a way that it have all necessary information such as sensor readings, data processing and the display of the data, and we have to upload our code to Arduino and sensor connections. So first we have to connect the BMP 180 sensor in any of the analog pin for measure the temperature and the pressure. And we have to connect the MQ135 in any of the analog pin for measuring the air quality. And also we have to mention the pin in our port and connect the DHT11 sensor to any of the digital pin. And in this case we are connected with the digital pin too, and connect the LCD also to the any of the analog pin for visualizing the weather data. Implementation, data processing. It processes the raw sensor data to extract the information about the weather condition. It calculates the derived parameters such as dew point, heat index, or air quality index. Display the output. It uses LCD display to display the visualized data in the user-friendly format. And also it updates time to time so that we can reflect change the weather condition. And the other benefit of the program is integrating with IoT platform. Now we can connect our Arduino based weather reporting system with the ThinkSpeed website with the help of the generic ESP8266 so that we can get the real-time weather data in a graphical or format, and also we can connect with the Twilio to get the weather report in our WhatsApp. So we have to set up the account, so create the project and configure the data stream to receive and store the weather information for our system. It uses APIs or library to provide the IoT-based platform sensor data for cloud storage, analysis, and visualization, and testing and calibration. So we have to test our weather reporting system on the various environment to show the accuracy of our program. And now here the code for your reference. The benefits of the IoT based weather reporting system is it helps to calculate the real time data, it helps in remote monitoring, infrastructural reliance, and improved forecast. Increased accuracy, data accessibility, energy efficiency, smart city planning. The drawback of our project is energy consumption. Using the sensor for a long time causes a frequent battery replacement, impacting the sustainability, and high initial cost, reliability, and accuracy, dependency on external services. These can be easily rectified by future in future. Finally, the IoT-based weather reporting system helps in the new era for the meteorological monitoring, promising more precisely, timely, and widespread weather information. The innovative approach holds the immense potential for addressing the evolving need of the various, fostering for a safer and more reliable society in the face of the unpredictable weather event. And thank you for everyone who are watching this video. And we have to specially thank our college and our mentor, Dr. Shakunthala ma'am, for giving us this wonderful opportunity. Thank you all.